Okay, so what we have here are called Pythagorean triples. These are sides of a right triangle that are whole numbers. So there are certain relationships between whole numbers that work out perfectly on right triangles. Now, not all right triangles will have these perfect numbers. Some of them will have some square roots, and they'll have radicals in them. And we'll get to those later. But these just work out so nicely, 3, 4, 5, 6, 8, 10, meaning that if one side, the short side, is 3, and the other leg is 4, then the longest side, which always has to be the hypotenuse, has to be 5. Doesn't that work out so nicely and neatly? That's why we call it a Pythagorean triple. Another Pythagorean triple is 5, 12, 13, where one side is, one leg is 5, the other leg is 12, and the hypotenuse is 13. Also, any of the triangles that are similar, meaning if you double them, these are similar triangles, 6, 8, 10 is twice as big as 3, 4, 5. So 6, 8, 10 is also a nice Pythagorean triple. All right, let's see. 6 squared is 36, 8 squared is 64, and 10 squared is 100. Does that work out? Yes, 36 plus 64 is indeed 100. So that works as a perfect Pythagorean triple, meaning that these are all whole numbers. We don't need to deal with any radicals. So Pythagoras loved these Pythagorean triples because they didn't have any radicals in them. Radicals of non-perfect squares, as we have been doing, are going to turn out to be irrational numbers. So irrational numbers is not something that Pythagoras was really into. And you'll watch a video on that as well. But today we're just going to do Pythagorean triples. Numbers that are whole numbers and work out really nicely. And so what you can do is, even if you don't know the third side of any of these, you can always use the Pythagorean theorem. So for instance, let's say for this, 10, 24, 26. Let's say I didn't know what 24 was, okay? Let's say that this leg right here, we just know that it's B. So what we're tasked with doing is figuring out what B is. All right, so we know that 10 squared plus B squared equals 26 squared, okay? We know that B has to be a leg, and 26 is the longest side, so that has to be the hypotenuse. So A is left over here. So this will be 100 plus B squared equals 26 squared. Now 26 squared is actually a little bit larger than what we had memorized. So today, if you want to, you can use calculators. If you don't have a calculator, you can use your computer, and there's a calculator on your computer. So I'm just going to figure out what 26 squared is, and I'll just do it long form here. So that's 36, that's 15, all right, cross that out, that's 12, and that's 5, all right. So that's 676. So 676. Now I'm going to subtract 100 from both sides to find out what B squared is. B squared is 576. 576 is one of the square roots that we did memorize, hopefully, and or perfect squares. And so the square root of 576 is 24. So B has to equal 24. And again, today you can use calculators if you like. And you're going to fill out a sheet where you have these missing sides of Pythagorean triples, and you can figure out those missing sides.